Hey guys, Mr. Henry here. Just starting this week off with a short video of an activity in Desmos. I'm going to post a link for this activity under today's extra practice, so you guys can take a look at it then. But as you can see, we get a short video clip here of a man being shot out of a cannon. He falls down, deploys a parachute, falls a little slower until he hits the ground. And our task is to draw a graph of the Cannon Man's height versus time. And so to start, he starts at the bottom. So I'm going to put that just about here. I'm going to use the dots. Just put a dot there. And then I'm just going to slide. We can slide this, and that will kind of help us make a more accurate graph. So it looks like after, I don't know if these are seconds, but after 1 second, let's say, he is about this high. So I'm just going to go ahead and try and make the rest of the graph pretty quickly here. The next point is a little higher. The next one is about here. And then this is about where he deploys the parachute. And then from there, it looks like he's got a pretty steady decline. So I'm just going to try and slide this a little further and put a point there. And I'm going to try and quickly connect these just so we can talk a little bit about what we're seeing. So there we go. And then this is the part where he's falling, and he falls until about this point there. From there, it looks as if the graph kind of follows a straight line. So I'm just going to add in that straight line there and see how we have done. So I'm going to click play, and what we'll be able to see is our parachute guy in blue and the actual one in green kind of side by side. So we just started at the beginning. So we can see I've been pretty close. A little bumpy over here. Deploys a parachute, and it seems like we got it pretty much exactly from then on. And so what I wanted to do is talk a little bit about this graph. So we can see there are basically two parts to the graph. The first part of the graph is curved, and then the second part of the graph is straight. And so if we think about what that actually is representing, we notice that in the first part, when he's shot out of the cannon, he comes out of the cannon pretty quickly, but then he slows down, right? And he slows down just as he hits the top. He starts falling, but as he's falling, he's getting faster and faster up until the point where he deploys a parachute. So if we're thinking about his speed, it's not really constant here. At the start, he's starting really fast, and then you can see he's slowing down. And then once he has started falling downwards, you can see that is increasing the speed. The speed is getting faster and faster. And then once he deploys the parachute, it's a pretty much straight line. And so we would call this sort of relationship linear. Basically, he is moving at a constant speed from this point on. Up until then, we would say that his speed is nonlinear, right? The speed is changing. At some points, he's going very fast, and at some points, he's not going very fast at all. Like at the top here, you can see he's barely moving. In the next video, we'll talk a little bit more about how we can describe distance time graphs. This was a height time graph, or distance from the ground. You could think of it as the y-axis and our x-axis being time. So in our next video, we'll talk more about those types of graphs and what we can learn from them.